Assalamualaikum warahmatullahi wabarakatuh, and hi, this is a video assessment for our course subject MAT183 Mechanics 1. We are from group 10 and our lecturer name is Dr. Roslah binti Arshad. My name is Muhammad Hanzala bin Shafi'i and my ID is 2022628034.
Hi, my name is Muhammad Nazmin Akib bin Muhammad Akib. My student ID is 2022480066.
Assalamualaikum. My name is Muhammad Syarhan Fatul bin Muhammad Sepian. Student ID 2022615346.
In this video, we will discuss about chapter 3, that is application of differentiation. So, first thing first, I want you all to know what is differentiation. Differentiation is a method of finding the derivative of a function. There are a lot of methods for differentiation, which is definition of derivative, product rule, quotient rule, chain rule, and implicit differentiation. In application of differentiation, analysis of function is one of the application of differentiation. There are two types of analysis of function, that is graph of polynomial functions and graph of rational function.
Now I will explain a solution for question A. To find the x-intercept, function x equal to 0. 0 equal to x squared in bracket x plus 3. And you will get the answer which is x equal to 0 and x equal to negative 3. Next, for y-intercept, substitute x equal to 0 into the function. And you will get the answer y-intercept equal to 0. Now I will explain the solution for question B. Step 1. Find the derivative f prime. And you will get the answer for f prime equal to 3x squared plus 6x. Step 2. Let f prime equal to 0. And you will get the answer for value x, which is 0 and negative 2. Step 3. Make the critical line. Step 4. Make first derivative table, which is interval from negative infinity until infinity. Step 5. Choose the correct sign. For increasing interval equal to negative infinity to negative 2, union 0 until infinity. For decreasing interval equal to negative 2 until 0. Step 6. Determine the extremum point. When x equal to negative 2, substitute to the function, you will get the answer is 4 and the maximum points is negative 2, 4. When x equal to 0, substitute to the function, you will get the answer for minimum point, which is 0, 0. Step 7, find the second derivative f double prime. You will get the answer, which is equal to 6x plus 6. Step 8, let f double prime equal to 0. And you will get the answer for x, which is negative 1. Step 9, make the inflection line. Step 10, make second derivative table. Interval from negative infinity to infinity. Step 11. Choose the correct sign. For concave up equal to negative 1 to infinity. For concave down equal to negative infinity to negative 1. Step 12. Determine the inflection point. When x equal to negative 1, substitute to the function, you will get the answer, which is 2. And the inflection point is negative 1, 2. And the last step, sketch the graph based on the maximum point, minimum point, and inflection point.
And now I will proceed into detail about analysis of rational function, where as you guys can see, rational function is different than polynomial function, whether by its graph and its structure, equation structure given. And as for rational function, its equation and steps to solve it is similar to the polynomial function. And in this video, I have prepared an example question for us to solve and understand the way to do it easily. And in this question, it asks us, uh, given a function fx equal to negative x over 1 minus x plus 4. And as you guys can see, the equation is similar to the polynomial function. So as for the first question, it asks us to find the x and y intercept. You guys can solve it as usual. And for the vertical asymptote and horizontal asymptote, our first objective is to find the vertical asymptote, where we need to make the equation given into one single fraction only, and then we let the denominator equal to 1 to get the value of vertical asymptote, where in this case x equal to 1. And for the analysis, we will use limit x approaching to our vertical asymptote value just now, and then we can take the sign only. As for horizontal asymptote, we need to do y equal to limit x approach to plus minus infinity fx, where in this case our fx is negative 5x plus 4 over 1 minus x. And for this, we just need to take the highest variable, where at the top we got the negative 5x, while at the bottom we got the negative x. So we will solve it, we will get that our y is equal to 5. So we can conclude that our vertical asymptote equal to 1, while our horizontal asymptote equal to y equal to 5. And then in the third question, where we will apply our differentiation, and in this question, first, for us to get the f prime x, we need to use quotient rule since it's a fraction. And after we got our f prime x, we will let it equal to 0, where we will find it will got undefined. So after we got undefined, we will take denominator only equal to 0, where when we rearrange it, we will get our value x equal to 1. After that, we got the value of x, we will put it for us to find our interval and to get our test value. And then after we got our test value, we will substitute it into our first derivative function just now. And after we got it, we just need to take the sign of the of the solution, where if it negative sign, it means it's decreasing at the interval, while if it positive sign, it means it is increasing. And as for this equation, you guys can see the function is decreasing on both interval negative infinity 1 and 1 infinity. As for the first question, where it asks us to find the concave up and down, we will do the exact same thing, but we will differentiate the first derivative function, not the function given. And after we do the same method, you guys will get that the fx is concave down at interval negative infinity 1, while it will concave up at 1 infinity. And now we will proceed where it asks us to find the inflection point. So for the inflection point, we will use the value from x2 prime x, f2 prime x, where we got just now is x equal to 1. We will substitute it into our first function given, our the equation given function. And after we substitute it, we will get a value. But in this question, we got the value negative 1 over 0. This means it's undefined. So that this means that in this particular function, inflection point does not exist. And after all of that question we have solved just now, we will apply it for the last question, where it asks us to sketch the graph. So first thing first, you guys will have to do the asymptote line, where we got that vertical asymptote is x equal to 1, while horizontal asymptote is y equal to 5. After that, we do the graph that where the x and y intercept, where we got just now our x-intercept is 4 over 5, while the y-intercept is equal to 4. And then, after we do that, we will apply our concave up and down, where the interval concave up and where is the interval concave down. And after that, if there are any inflection point, we will apply it on our graph. If they are not, you guys will get this kind of graph for your answer. That's all.
In conclusion, analysis of function is one of the example for application of differentiation. There are two types of analysis of function, that is polynomial function and rational function. Even though they are different, but the steps are same, which is what we have learned at the video. I think that's all from us. Bye bye.